Basic details of GIS Insulated EHV Substation are being narrated by Sanjay Kumar Srivastava, retired DGM Power Grid Corporation of India Limited for only information purpose. All EHV engineers know the details of GIS EHV Substation, but as with the system, the basic information fades away. It is the site experience that keeps the high-level information in mind, but basic information do not fresh. That is why the module is being presented. You are advised to view the full video and comment. If you feel the module is useful, then you may please like the channel. If you are new on this channel, please subscribe the channel. Basic description of GIS Insulated EHV Substation. A GIS Insulated Substation, GIS, is a high-voltage substation where the major electrical components are housed within a sealed, grounded metal enclosure and insulated by sulfur hexafluoride, SF6. This design allows for a compact footprint, making it suitable for space-constrained areas and harsh environments. Origin of GIS technology. GIS technology originally began in Japan in the 60s, where there was a critical need to develop substations with a greatly reduced footprint. GIS was slowly adopted by various other countries over the following years. After about 5 years of evaluation and testing, GIS system construction increased to about 20% of new substations in countries with severe space limitations. For countries with space readily available, the higher cost of GIS relative to AIS has limited special needs cases. In the US, only about 2 to 5% of new substations are constructed as GIS. Clearances for GIS, roughly a tenth of that for AIS. With GIS technology, the clearance needed for phase-to-phase or phase-to-ground for all equipment is much less than that of an AIS or air-insulated substation. The total space required is roughly a tenth of that needed for a conventional AIS facility. While the conventional AIS requires several feet of air insulation to isolate a conductor, SF6 GIS insulation only needs inches, allowing a GIS facility to fit into areas far of a AIS facility. A GIS is mainly constructed where real estate space is expensive or scarce. Environmentally protected system GIS technology is a good choice to use in Arctic or desert locations, as it can be enclosed in a building which is environmentally protected from extreme conditions. In addition to protecting the system components from extreme heat and cold, technology encloses the electrical components within a Faraday cage which shields the system from potential lightning strikes. But SF6 is a greenhouse gas, and proper handling and disposal procedures are necessary to mitigate environmental impact. High voltage installations GIS insulated technology becomes more desirable as the voltage requirements increase. As an example, the footprint of a 765 kV conventional substation is considerably large. A station footprint of this sized station is significantly less were it to employ GIS. Approach to the expansion of existing AIS. One approach to the expansion of existing AIS is mixed technology switchgear or hybrid GIS. This approach is especially suitable for the expansion of an existing substation without requiring large areas of additional real, which is often unavailable. This design uses GIS breakers, switches, and voltage current transformers with interconnections between the breaker positions and connections to other equipment using air-insulated conductors. Disadvantages of GIS systems. Times system cost is higher compared to that of a conventional AIS. Times delivery of SF6 gas to the site can be problematic. Times GIS substations are indoor type, requiring a separate building. Times maintenance are critical to reduce conductive particle contamination. Times particle or moisture contamination inside the compartment causes flashovers. Times outages can be extremely long, and the damage to the system will normally be severe following a fault condition at a GIS. Times access to live parts for maintenance is more problematic and harder to diagnose without gas reclamation and disassembly of the modules. GIS substations applications. GIS substations are used in various applications, including power stations, transformer substations, and railway systems. They are also well suited for integrating renewable energy sources and smart grid. Due to the protected environment, GIS requires less maintenance compared to AIS. The compact and enclosed design can be more visually appealing in urban settings. GIS systems typically have a higher initial investment cost compared to AIS. GIS Insulated Substation comprising of operating devices, accessories and auxiliary equipment shall be metal-enclosed SF6 gas type as per IEC 62271-203. GIS shall be indoor-outdoor type. However, indoor type shall be preferred considering its long life with respect to easy maintenance. The ladders and walkways shall be provided wherever necessary for access to the equipment. There are two types of enclosure: first single-phase and second three-phase enclosures. Systems up to around 170 kV, all three phases are often combined into one enclosure. Systems above 170 kV, the size of the three-phase becomes too large to be practical. So a single-phase enclosure design is used instead. No established performance differences exist between the three-phase enclosure and the single-phase enclosure GIS, with some manufacturers using single-phase enclosures for all levels of 765-400 kV system. GIS shall be single-phase type. 221-32 kV system GIS shall be three-phase or single-phase or a mixture of both. 33 kV GIS shall be three-phase type. The arrangement of compartments shall be such as to facilitate future extension of any make on either end without drilling, cutting or welding on the existing GIS. It shall not be necessary to move or dislocate the existing substation base for adding the equipment. GIS shall be total inadvertent touch of any of its live parts. It shall be protected against all types of voltage surges. GIS shall include but not be limited to the following: circuit breakers, disconnecting switches, isolators, maintenance earthing switches, fast-acting earthing transformers, voltage transformers, bus and elbow sections, cable end enclosures, SF to air bushings, GIS to transformer direct connections, surge arresters, density switches, secondary cable, etc. Support structures for the GIS, insulating SF, local control cubicle, monitoring system. If you feel the module is useful, then you may please like the channel. If you are new on this channel, please subscribe the channel.